Hello and welcome. This is Chapter 0, Section 5, Part B. Here are our main objectives for today. So let's first start with just a throwback what we did yesterday, except let's do a word problem with a linear system of equations, meaning just two variables. So we're going to have a sum of two numbers is 56. The smaller number is 8 less than the larger number. So let's start by defining things. So let S equal the smaller number, and let's do L equal the larger number. Now, when we do math and word problems, we should define variables. Then we know what we're talking about. So when someone looks back or you look back, we can figure that out. So if I think about my small number plus my large number, the sum of two numbers is in fact equal to 56. Now, I know that smaller number is 8 less than the larger number. So what I'm going to say is the smaller number is going to be 8 less than the larger number. So if I take the large number and I subtract 8 to it, it does in fact get smaller. So therefore, that is how I would write that. Now I have a system of linear equations with two variables, S and L. And you could use X and Y, but S and L fits very well. Now we can solve these any way we like. I'm going to use substitution because we have S equals L minus 8. I'm going to substitute that in right there. So let's plug this in right here. So now I have L minus 8 plus L is in fact equal to 56. So combining like terms, we get 2L, and then adding 8 to the other side, I get 64. Divide by 2 to get that L. Let's move this up a little bit. We in fact get L is in fact equal to 32. Now, we will have to double check this, but let's first find that small number. The small number, we can do it a few different ways. You can plug it back in here. 32 minus 8 is in fact 24. So S equals 24 if we just substitute that in. Now, do these add up to 56? Well, 32 plus 24 is 56, and then 32 minus 8 is in fact 24. Therefore, this does in fact work. Double check by plugging it back into both equations to make sure it works for both. So let's talk about systems in three variables. So when you think about one variable, first off, so one variable, meaning we would just have a number line. So remember when we had just a number line, one variable, we just said like X, the point is 4 or something. That would be it. It's just a dot. It's a point. So one dimensional or one variable will just be a point. Now, if I think about two variables, what we just did, like an X and a Y, that is when we throw in both an X and Y coordinate system. So now we have our X's and our Y's, and now we have a line for that. So this will be linear when we think about two variables. Now thinking three variables, so when we go to three variables, now instead of so this is 1D, this is two-dimensional, one-dimensional, two-dimensional, this is going to be three-dimensional, which if we think about it graphically, we will have both an X and a Y, but we'll also have some sort of a Z plane or whatever that is, and they can rotate it however you want. So sometimes we do like X, Y, and Z. There's a bunch of ways you can do it, but it ends up being three-dimensional, or in this case, we will have a plane as our answer. So it'll be like a sheet of paper, if you remember when we talked about geometry. So our first example is very, very, very simple. I'm going to set it up in something called a triangular form. So this is extremely nice because we have this in something called a triangle or triangular form. Now we can do this because now we can just what we call is back substitute. And we're going to be doing this quite a bit as we get into it. So we can just take Z and plug it in here, and then we're going to find Y. Y, if I plug in Z, we get 5Y plus 9 is 4. Subtract 9 to both sides, we get -5, and Y is in fact equal to -1. So then we plug this in here, and we plug the Z back in here. So therefore, we have 5x plus 6 times Well, we knew y is -1 minus 6 times, well, z was 3. So that will give us my -9. Now we just have to solve that for x. So 5x minus 6 and then minus 18 is in fact equal to -9. When we do this, well, that's -24. We add it over, which is 15. So 5x equals 15. And therefore, x is in fact equal to 3. So literally, we're just going to substitute z in here, find y, take z and y, plug it into here, and then you find that you have x, y, and z. So my answers as a ordered triple, not an ordered pair, there's 3 answers. We have an ordered triple. So this is called an ordered triple, and you can keep going further and further. If you have 4 answers with a 4-dimensional figure, you can do that. It gets a little bit more interesting to think about because it's, well, after 3 dimensions, well, 4th dimension is interesting. So yeah, but we'd have an ordered triple with x, y, and z here. So let's talk about a problem that will be a little bit more strenuous. The best way to start these is choose a variable to eliminate. And we're going to have to eliminate it from all of these equations. So let us look at this. Which variable looks like the easiest to get rid of? So we have a 3x, a 2x, a 4x. Those are all different numbers. 3y, y, and 4y, they're all different numbers. We got a z and a negative z. Those look like they're easy because I could just add these 2 equations and the z's are gone. And then I could just add this twice to this, like 2 of these, to get that gone. So I'm going to choose z. So I'm going to pick, I choose, just like Pikachu, I choose z. That's what I'm going to eliminate. So let's go ahead and start doing that. So let's think about this. So let's add, if I call these, this is equation 1, equation 2, equation 3. I'm going to add equation 1 and equation 2. So we have 4x plus 3y. I'm going to rewrite this down. So 3y minus z is in fact equal to 0, and we have negative 2x plus y plus z is in fact equal to negative 8. If I add these 2 equations, I get negative 8 is equal to, the z's go away, and we have 4y's and we have 2x's. So this is now my new equation number 4. So we have 3 equations, and we eliminated our z in equations 1 and 2. Now there is something we have to do. We have to use all 3 equations. So we must use all 3 equations. Otherwise, we will not get a solution to all 3 equations, which it will probably give us a weird endless loop where we can't really solve it. So we could get an answer for both of these that is linear, or it could be no solution. These planes might not intersect at all, which is interesting, or they might intersect. And if planes intersect, it is a line, so the answer would actually be linear. And there's multiple lines. And that gets into some interesting stuff we'll talk about maybe later as we get into some more advanced math, but not too much. So now what we're going to do is we still have to eliminate z. I chose z, but we haven't used equation 3 yet. We used 1 and 2. So let's eliminate z from equation 3. So let us do something. Well, let's add 2 of equation 2. So we're going to double this to get 2z to add this. So let us do 2 times equation number 2. And then we're going to add this to just equation 3. So just as kind of like a notation, we're doubling equation 2 and we're adding it to 3. So if I doubled equation 2, I get negative 4x, because we're timesing this all by 2, plus 2y plus 2z is equal to negative 16. Make sure we're times this by 2, times this by 2, this times all those by 2. And then I'm just rewriting down equation 3. So we knew that equation 3 was 3x plus 4y, and then minus 2z's is in fact equal to negative 4. Now we said we're going to add those, so let's add those, and we're going to make our new equation 5. So we get a negative x here, we get a positive 6y, and we get a negative 20. So now we have 2 new equations. So we now have to solve, the last step is solve equation 5 and equation 4. So 4 and 5, sorry, I wrote them a bit differently and said them differently. But we can solve it any way we want. I'm just going to probably use elimination just because that's easier. So if I have 2x plus 4y, that's a 4, is equal to negative 8. And I'm going to write this above it. So we have negative x plus 6y is equal to negative 20. I'm just going to double this equation 5. So times this all by 2 to get that the x's can cancel out. So I'm just going to rewrite this over here. If I double it, so we still have the 2x plus 4y is equal to negative 8. So then I have to double the other equation. So this will be negative 2x plus 12y is equal to negative 40. Now we can add those and get our equation. Well, we have 16y's, the x's cancel out, is equal to negative 48. Now that looks nice because it will divide nicely. It doesn't always have to, but I'm usually fairly nice. Divide by 16 both sides, we get y is negative 3. Answer numero uno. So now we can substitute it back in here into one of these, either equation 4 or 5. I'll probably plug it in here because I want to get x, and this is basically x. So if I plug in negative 3 here, just as an FYI, I get negative x plus 6 times this negative 3 is equal to negative 20. And then we can, add the 18 to the other side. So it's negative x is equal to negative 2, or x is in fact a positive 2. Now we got x is positive 2 and y is negative 3. The last thing is just plugging in all of those back into the original equations. Either one of them, any of them. I'm going to probably choose this one because we have a positive z here. So let's just choose this one. It's easier to substitute it into equation 2. So we have negative 2, and we said that x is in fact 2, plus we knew that y was a negative 3, and then plus z is negative 8, sorry, negative 8. And then we have to solve that. So in this case, we have negative 4, negative 3, negative 7, add it over, it gives me a negative 1. So we get that z is in fact negative 1 here, and then we can write it as an order triple. We add 2 for the y value, negative 3 for the 2 for the x value, negative 3 for the y value, and negative 1 for y and z. If you want to go ahead and check this one, try it. Again, choose a variable to eliminate. It looks like it might be easy to do x's, and actually y's look pretty easy. You can get rid of those real quick. Z's look more difficult, so either choose x or y to eliminate it. Pause it. I will show you an answer. I won't do all the work, but I will show an answer very shortly. So if you did try it, you should have got x is 5, y is negative 1, and z is 3. If you need help, just let me know. I can help you at any time.